All right, let's talk about transforming sinusoidal functions. So, um, in class, we talked about a sine function. And a sinusoidal function just refers to any function that has sine of x or cos of x in it. So what we're going to do is we're going to fill in this table of values for cos function, and then we're going to graph it on top of this function that we already have. So you can see already we have a sine function. We have at 0 degrees, we start at 0. At 90 degrees, we're at 1. At 180 degrees, we're back at 0. At 270, we're at -1. And at 360, we're back at 0. So you'll remember that when we go all the way around, our sine function actually came from what happens when we're traveling around a circle. So we had a circle, so you can imagine it as like a Ferris wheel, right? If you were to start on one point of your Ferris wheel, right? And let's say that this was, I don't know, a Ferris wheel that went underwater or something, right? So this is our height away from the water line. And then as we go up the Ferris wheel, we travel a certain angle theta, and the height away from our Ferris wheel was just going to be the radius. So our height equals the radius times sine of that theta. And if our radius is 1, right? If our radius is 1, then that just means that the height is going to equal sine theta. Oops. That just means that our height is going to equal sine theta. So that's what we filled in, and we found that when we went all the way around the circle for different angles, it took us 360 degrees to get back to our starting point. So we call this a cycle. So that means that this is the pattern that is being repeated over and over again. And the horizontal part of that cycle, the degrees, is our period. So our period, in this case, so this was one cycle, and our period is equal to 360 degrees. So let's look at what cosine is going to look like. So this one is sine theta. Let's do a new one for cos theta. I'm going to change my colors. Let's do the cos theta in green. Okay, so if I type into my calculator cos of 0, I get a value of 1. So that means at 0 degrees here, I'm going to start at 1. Next, I can do cos of 15. You'll find it equals roughly 0.97. Cos of 30 is going to be 0.87. Cos of 45 is 0.71. Cos of 60 should be exactly 0.5. Cos of 75 is going to be about 0.26. And then the cos of 90 is going to be 0. And then you'll notice something interesting happens. Our numbers are repeating, but now they're going to get negative. So the cos of 105 is going to be negative 0.26. The next one's going to be negative 0.5, and then so on, negative 0.71, etc., etc. So let's look at what this is happening, what's happening on our circle. Oops. So on our circle, before we were looking at the height, right? So now, if I were to travel a certain angle around my circle like this, instead of the height that I was looking at, what we're actually looking at is this adjacent part. We're looking at the distance away from the center that we are around each part of the circle. So this is us at 90. You can see that our distance from the center of the circle is 0, right? And then if we cross that 90 threshold, well, now our distance is going to be negative, right? Because we're going in the opposite direction. So it's going to be increasing all the way to 180, where it's going to be -1. So we started at +1 over here, and now we're going to end up at -1 over here with 180. So these numbers are actually just going to be repeating. And this one is going to be -0.97. I'll make my negative sign a little better, right? And then once we cross that 180, we're still negative, but we're going to be going back to 0, because once we get to 270 over here, we're back at 0, and then it's going to be positive until we get back to 1 at 360. So we can actually just fill in these values. We don't really need to calculate them anymore. Oh, these are all negative. 0.87, -0.71, -0.5, -0.26, and then 0. And then we're going back up. All right, so now when we start graphing this function, we know that we're going to have a point 0 at 90 degrees. We know that at 180, we're going to be way down here at -1. We know we're going to be back at 0 for 270 and back at 1 for 360. So all of these other points are going to be just kind of in between there, right? So at 30 degrees, we're at 187. Oh, sorry, we're at 0.87. So that's roughly over here. This would have been over here. At 60 degrees, we're exactly at a half. At this one, we're at -1/2, and you know, well, not exactly there, but kind of, you know, estimating where our points are going. And then, of course, they are symmetrical. So we can just kind of fill in our table, and we're getting this lovely curve. So if we were to continue this, right, I would get my same points over here, and then I would end up at 1. So I would be getting my curve just kind of following like that. And you'll notice that my curve looks a lot like a sine curve. So this one is cos theta. And in fact, it is actually the same as a sine curve, only it's been transposed. So we have transformed, our sine function, just moved it over, right? We just moved it over to the left by 90 degrees. So in our next videos, we're going to look at actual transformations of sine functions and cosine functions.